This is a continuation of lecture 2. This is part 2, and as I mentioned before, part 1 is a cursory overview, and these are important details that are not included in the readings. So I want to share with you the page so that you can see what I'm talking about. And here I'm going back to the material that is presented in my tentative schedule, and then I go to the lecture notes. And the lecture notes, I begin here with part 2. This is advanced material or kind of important details that are missing. As I mentioned before about the advanced organizer is a way in which you can conceptualize measurement, but also statistical inference, causality that we try to infer. But most importantly, what it does is it gives us a common framework in which we can discuss a lot of these concepts. So to begin with, statistics are a tool, and they, as I mentioned before, it's to help us quantify our uncertainty. We can identify underlying relationships. We can create order in what appears to be disorder. We can communicate complex relationships. So you can see here that statistics is a tool that provides us with a method by which we can quantify our uncertainty and persuade others. And we persuade others in a whole series of ways. And what I want to draw your attention to is a series of things in which we can use statistics both as a tool for quantifying our uncertainty, or what we can use is we can use it as a bat to beat down people. And if you fail to understand and appreciate statistics in any way, oftentimes the bat is used against you. And so that's the reason why I feel strongly about people learning statistics, because I think it's important for everybody to be able to understand when you're being persuaded and when you're actually being taken advantage of. So Daryl Huff did an outstanding job of identifying ways in which statistics are misused, but I think in many ways we can combat that simply by learning these methods and not using them and not be falling prey to them. I want to give you some specific examples, and I'm going to go through that in class, just so that you can understand some of these really, really subtle details about statistics. But probably one of the most important things is to differentiate between what's observed, what's expected, and what we miss, and those are called residuals. So these concepts usually are not covered in undergraduate statistics classes. They are to some degree if you have a highly technical class, but in social and behavioral sciences, this is more advanced stuff. But it's really critical for understanding how statistics are used, but how they're actually used in a way to understand what we know and what we don't know. And it's really understanding what we don't know that's our uncertainty. So here is this is an equation. Well, and I don't want you to get too hung up on equations, but really it's this little sigma, this little curly thing with a square of it, that's variance. So we have residual variance is equal to observed variance minus expected variance. Okay, so what are these parts? Well, observations. Remember, I said everything revolves around variance. So we have observations, and those observations are literally the data that we collect. We collect those, and that's what goes under observed, okay, the middle part. And then you'll see here, this is observed data, okay? So we have some observed data, and this is random data that I generated at some point. Well, let me shrink this up. It didn't plot out completely on this page. This is when I was having problems with LaTeX before, but the y-axis is just the level of the variable, and it doesn't really matter a whole lot. And so what we have is we have a scatter plot of all of these values, and so we have an x variable and a y value, and this is not all that interesting. It's random data. So we have observed data, and that's the observed variability. Okay, so the observed variance that we have, typically we're interested in our dependent variable, that's the y-axis. and our x-axis is our predictor. And you can see the variability here. It's probably normally distributed, and it doesn't look like it's a very strong relationship, but let's take a look. What's expected? Okay, observations we would expect given a model or given something. Now remember, as I talked about univariate statistics, the expected value of a single variable, if we know nothing else, is the mean, right? Well, for a bivariate model, the expected value is a regression line. That's what we have here. And so we have observed data and an expected line. So we have x, this value that ranges from 0 to 10, predicting values that are probably from -4 to +4. This expected line is for every value of x, you can have an expectation of y. And that's what a regression line is. Now, what we fail to account for is what's called the residual, and that's the difference between what's expected and what's observed. So go back to our equation up here slowly. The residual is equal to what? The variance observed minus the variance expected. All right, now what does that mean? That means for every observation that we have, whoops, let me go here. We have an observed value and it deviates from the expected line. So while there's a value up here that's above the expected line, there are some values down here that are below the expected line. So these are the residuals, and the residuals are where we're in error. Okay, people call them either residuals or error depending on your bent, and I'll talk about that more in class. But at any rate, the three terms that we want to know about are here, and what we're discussing is observed, expected, and residual. So the expected value is that red line. In a univariate, the expected value is the mean. And this is a bivariate model, so we have a bivariate regression, and the expected value is the regression line. So for any value of x, we can get an expected value of y. The deviation between the expected value given x is what we observe and what's expected. Okay, now we can do a residual plot where this is our predictor. Still, it ranges from 0 to 10. And these are our residuals. Our residuals, remember, are what is observed minus what is expected. And because of that, we get these values, and we want to make sure that the predictor is unrelated to it. And it is indeed. So as I mentioned before, this is kind of some advanced material that I'm going to go into more depth during the lecture. These videos are just to introduce you to the topic, to get you to think about them and start generating some questions. So when you come to class after watching these videos, please ask questions about these. Part 3 is going to be advanced material, much more advanced material, but for this part, I recommend that you watch video 3 because statistical power is going to be something that comes back routinely. So I'm going to end here, and I'll start video 3 or part 3 shortly.